Good evening Queensland, also a special welcome to our interstate and overseas visitors. My name is Christopher Whitehurst. I will be presenting the spring and summer outlook for the 2017 and 2018 severe weather season. Well, it is that time of year again where we have sat down and discussed what is likely to happen this severe weather season. I will talk about the sea surface temperatures, bushfires, extreme heat waves, rainfall, severe thunderstorms, and tropical cyclones for this severe weather season. We have been doing some research on decades past, and we have seen an alarming rising trend in temperatures globally, which is likely to be responsible for the increase in events such as extreme heat waves, bushfires, floods, storms and devastating cyclones and hurricanes. So is global warming going to be the extra factor that we now have to look at when predicting for severe weather events? For instance, our warmest year on record was 2013, and third warmest, 2014, were both non-El Niño years, illustrating that essentially most years have the potential to break heat records. Our rainfall prospects are relatively positive for this wet season. However, with no primary dominant global driver, the ongoing heat anomalies of recent years will almost certainly continue. From what we have seen at the moment, our country no longer requires El Niño conditions to endure record high temperatures and prolonged drought. As we know, Australia has just recorded its warmest winter on record. We are now entering the severe weather season. Our two main global climate indicators, the Southern Oscillation Index, INSO, and the Indian Ocean Dipole, IOD, which are similar to what we had over the past 4 years. After looking at the conditions over a 5-year period, over the past years, all of which produced severe thunderstorms, bushfires, heat waves and tropical cyclones. Now let's take a closer look at our climate drivers, both of Australia's major climate drivers at this time of year. El Niño, the Southern Oscillation Index, INSO, and the Indian Ocean Dipole, IOD, remain neutral, but has been a weekly positive, though below the positive IOD threshold. For the past 7 weeks, 3 of the 6 climate models suggested positive IOD thresholds may be reached during spring, but it may now be too late to become an event. If a positive IOD is eventuated, it would be short-lived, as events typically decay by December. The Southern Oscillation Index is also neutral, despite the eastern tropical Pacific Ocean's temperatures cooling over the past 2 months. Sea surface temperature anomalies for August show sea surface temperatures were close to average along the equator in the Pacific Ocean. Warm anomalies were located across most of the South Pacific, with the strongest anomalies occurring off the East Australian coastline and to the east of New Zealand. Large parts of the North Pacific Ocean between Indonesia and Japan also had sea surface temperatures of more than 1 degree warmer than average. So with the Pacific Ocean sea surface temperatures that may approach La Niña thresholds during spring, before easing back towards normal in summer. So we need to take a look and include sea surface temperatures around the Australian coastline, as well as high-pressure systems to the south of the country. These highs are encouraging a more easterly flow across the country, which can increase rainfall for the eastern parts of the country. These influences from the Indian and Pacific Oceans are likely to be competing, with a weak drying influence in the Indian potentially cancelling out a slightly wet influence from the Pacific. So in short, we're in a neutral state, allowing local conditions to become the major force controlling our weather patterns through 2017. Let's now have a look at temperatures for the severe weather period. So the heat trend seen in winter is likely to continue into the severe weather season, with maximum temperatures from October to April likely to be above average across most parts of the country. The trend is that every Australian capital has recorded at least 5 consecutive years with above average maximum temperatures during the severe weather season. Although Sydney has now recorded 17 consecutive warm seasons with temperatures above average, Melbourne and Hobart have 15 years, followed by Perth, which has 11 consecutive years of above average temperatures. So, with it being said, there is a high probability that once again all capitals will be warmer than normal. Considering the hot weather will follow an exceptionally dry winter and start to spring, the Bushfire and Natural Hazards Cooperative Research Centre, CRC, are predicting above average fire potential through much of the nation, including the forested regions of Victoria and eastern parts of Queensland and New South Wales. Yearly temperature variations in Australia are linked to the shifting pattern of the sea surface temperatures. Let's move on to extreme heat waves. Now with spring here and summer coming, there is the added potential for extreme heat waves. Australia has just recorded its warmest winter on record for maximum temperatures, despite neutral phases of the Indian and Pacific oscillations. Temperatures are likely to remain above average across much of Australia through the warm season, increasing the risk of extreme heat waves, although heat waves are extremely rare along Australia's east coast, with Brisbane, Sydney and Hobart averaging less than one every 10 years. Don't get me wrong, I'm not saying that we won't see any heat waves. I am saying we're unlikely to see any extreme heat waves through Brisbane, Sydney, Hobart, and Darwin. However, this is also changing, and not for the better. The frequency of heat waves has increased over recent decades. While there is no universal definition of a heat wave, we use the 5x5 rule, 5 consecutive days where the maximum temperature equals or exceeds 5 degrees above the average for the location in question. On average, we can expect to see 1 or 2 heat waves across southern Australia during the severe weather season, with the summer months producing the most extreme examples. Let's now take a look at the rainfall for our country. So add the potential for heat waves with a very much possible weak La Nina, which may lean towards the end of neutral by January at this stage on the ENSO scale. These two factors will help to trigger some fierce severe thunderstorms this season. So with the added heat and a possible weak La Nina, we're also likely to see the Coral Sea become more active than it has in the past few years as well. Australia is in the midst of a non-El Nino and a slightly positive IOD period of severe rainfall deficiencies. Winter was the 9th driest on record for our country, followed by a record dry start to spring for parts of the east coast. Thankfully, with the lack of a dominant global climate driver like El Nino, which should allow rainfall patterns to return to normal as we transition into the warmer season, the possibility of a weak La Nina is also a factor in the swing back to average rain for most of Australia. Rain and flooding across Australia are both strongly linked to the constantly shifting pattern of sea surface temperatures through the Pacific and Indian Oceans. La Nina and negative Indian Ocean Dipole (IOD) conditions cause an increased rain and flooding, while El Nino and a positive IOD status bring less rain and increase the chance of drought. Australia regularly encounters 2 types of flooding between October and April. One is flash flooding. A flash flood is a rapid flooding of low-lying areas following short-lived heavy rain, often the result from thunderstorms. Flash floods can occur in any part of Australia but are particularly severe in urban areas, where drainage systems struggle to cope with short bursts of torrential rain. 2 is river flooding. A river flood occurs when runoff from widespread rain causes a river to break its banks. Unlike flash flooding, river flooding normally lasts for days or even weeks. Across northern Australia, the chances of an early or late rainfall onset for the first significant rains after the dry season are roughly equal. There is a slightly increased likelihood of an early rainfall onset in parts of northern Queensland and the Pilbara in Western Australia. The northern rainfall onset occurs when enough rainfall has fallen to stimulate plant growth after the dry season. This is defined as the date when at least 50 mm has accumulated after the 1st of September. In general, parts of coastal Queensland and the western top end receive the first useful rainfall by late October or early November, and this spreads further south and inland over the ensuing weeks. The southern inland regions of the Northern Territory and western parts of Western Australia usually have the latest northern rainfall onset around mid-January, so it has been a slow start to September. However, things will increase from the beginning of October, which is close to above normal. So we're likely to see an active period towards the beginning of October. Then things die down with near normal conditions till January. January will likely go off with a bang as conditions are expected to be just shy of well above normal. March at the moment looks to be right on the money for normal conditions, while April will be just shy of well above normal conditions by what we're seeing at the moment. So in short, Brisbane is likely to be wetter than average and wetter than last year. Sydney is likely to be close to the average. Canberra is likely to be close to the average and also wetter than last year. Melbourne and Hobart are likely to be close to the average. Adelaide is likely to be close to the average and drier than last year. Perth is also likely to be close to the average and drier than last year. Last but not least, Darwin, which is also expected to be close to the average and drier than last year. Let's now have a look at the severe thunderstorm outlook. There are signs of a weak La Nina, which may briefly develop over summer. However, the low intensity and duration of the event, combined with competing factors from the Indian Ocean, results in this scenario having only a minor influence The thunderstorm season is likely to be extremely active across northern and eastern Australia, as we're in a neutral phase of the Southern Oscillation Index, or a weak La Nina conditions combined with high land temperatures, which should increase the number of days with suitable conditions for thunderstorm development. Apart from the southwest corner of Western Australia, severe thunderstorm activity tends to peak across Australia between September and April. Southeast Queensland and northeast New South Wales are the most severe thunderstorm-prone regions of Australia, with Brisbane and Sydney the two capitals most affected. Severe thunderstorms are most frequent across southeast Queensland and northeast New South Wales during neutral years, that is years which are neither La Nina nor El Nino. La Nina years have the least number of severe thunderstorms in Queensland and northern New South Wales due to stronger, cooler easterly trade winds on the coast, which reduces instability. In La Nina years, however, may increase thunderstorm numbers over southern Australia, which is due to the increased amount of available moisture. So we will now take a look at our predicted days of severe thunderstorms for the capital cities and territories. Let's start with Brisbane. Here in Brisbane we average 20 severe thunderstorms a year. We are predicting at least 24 to 28 severe thunderstorms this season. Moving on to Sydney. Sydney averages 17 severe thunderstorms. We are predicting 18 to 22 this season. Moving on to Canberra. Canberra usually averages 15 severe thunderstorms. We are predicting 14 to 18 this season. Now we'll take a look at Melbourne. Melbourne averages 9 severe thunderstorms. We are predicting 8 to 12 severe thunderstorms this season. We will now take a look at Hobart. Hobart has an average of 4 severe thunderstorms a season. We are predicting 2 to 6 this season. Moving on to Adelaide. Adelaide usually has an average of 6 severe thunderstorms. We are predicting 4 to 8 severe thunderstorms this season. Moving on to Perth. Perth has an average of 5 severe thunderstorms a season. We are predicting 3 to 7 severe thunderstorms for this season. As for Darwin, it's like a box of chocolates. You never know what you're going to get in regards to thunderstorms. In the wet season, you may be asking what defines a severe thunderstorm. Severe thunderstorms are classified by if they generate any or all of the following: damaging wind gusts, 90 km per hour or more, large hail, 2 centimeters in diameter or more, very heavy rainfall, conducive to flash flooding, and tornadoes. While Australia has nothing to match America's tornado alley, we still get about 16 tornadoes every year. Some places are more tornado-prone than others. The most common tornado spots are the southwestern coast of Western Australia, as well as southeastern South Australia, and over the border into nearby Victoria, and the area around southeastern Queensland, and the far north coast of New South Wales. When we look at tornado occurrence in Australia, we find 2 peaks, including a summer peak around November, December and January, but a significant proportion happen in winter, especially in the southern coastal part of the country. Let's now take a look at the tropical cyclone outlook. With no primary dominant global driver this season for cyclones, so the outlook is less certain. The Australian tropical cyclone season runs from November to April. There is extreme variability in cyclone numbers with a general decline in numbers over the past few decades. On average 11 cyclones that do develop or move over Australian waters from 90 degrees east to 160 degrees east. Each year, however, generally less than half actually cross the coastline. Cyclone activity typically increases during La Nina years, particularly in the Coral Sea, when sea surface temperature anomalies rise off Australia's northern coastline, while cyclone numbers are decreased during El Nino years. After the record quiet cyclone season of 2015 and 2016, cyclone numbers returned to near average last year with 9 named systems in the Australian region. Neutral or weak La Nina conditions are favoured across the Pacific. Combined with sea surface temperatures near average off our northern coastline, this should ensure another season with a near average number of tropical cyclones. However, the observed decline in cyclone numbers over recent decades favours a slightly below average number. Between 7 and 11 tropical cyclones are likely over Australian waters this cyclone season, of which 4 to 5 should make landfall. This represents an average to slightly below average season. Around 5 cyclones can be expected off the northwest coast of Western Australia. 2 are expected to impact the coast, one of which is likely to be a severe Category 3 or above for this season. Last season we saw 7 tropical cyclones in the western region with 2 Blanche and 22U, making landfall. 2 to 3 tropical cyclones are likely off the north coast between the Kimberley and Cape York Peninsula, 2 of which should cross the coast. Last year we saw 3 tropical cyclones, with none making landfall at cyclone strength. 2 to 3 tropical cyclones are likely off the Queensland east coast, with 1 coastal crossing likely as a Category 3 or above for this season. Last year we saw only 1 severe tropical cyclone named Debbie in the Coral Sea, which made landfall as a Category 4 system. That now brings us to a close of the severe weather outlook for this season. We hope you enjoyed this presentation, and we thank you for watching. This is Christopher Whitehurst for QSCHW.